All right, I'm going to go over the homework in lesson 2.1, numbers 2 through 5. In the city of Rectangulus, all the streets running east to west are numbered, and those streets running north to south are lettered. The even-numbered streets are one way, east, and the odd-numbered streets are one way, west. All the vowel-lettered avenues are one way north, and the rest are two-way. Can a car traveling south on S Street make a legal left turn onto 14th Street? Explain. Okay. So Rectangulus, all streets running east to west are numbered. So like 1, 2, 3. And those running north to south are lettered, like A, B, and C. The even-numbered streets are one way east. Okay, so even, one way east. So that would be like if we had 2 or 4, it would be going east. And if you recall, north, south, west, east. That's like we. And they're going to be even numbered one way east. So that's going to be this way. And then the odd numbered streets are one way west. So 3 would be going that way. 5 would be going that way. All the vowel lettered avenues are one way north. So vowel, that would be like I or O. That would be one way north. And the rest are two way, right? So if I had something like S or T, I can go either north or south. Okay. So the question is, can a car traveling on S Street make a legal left turn onto 14th Street? So can a car traveling on S Street, so S Street's a consonant, so that means he can be going either north or south. And can he make a legal left turn onto 14th Street? Okay, so he's traveling south. Let's go ahead and... So he's traveling south on S Street, going down that way. And let's do like, so here's 13th Street, and that's odd. So that's going this way. 14th Street is even, so that's going that way. And so, yeah, from that perspective, he would be turning left. That would be left, and that would be a right turn if you're traveling in that direction. So, yes. The answer is yes. He can take a left turn on a 14th Street. Okay. Next question, number 3. Midway through a 2,000-meter race, a photo is taken of 5 runners. It shows Meg 20 meters behind Edith, and Edith is 50 meters ahead of Wanda, who is 20 meters behind Olivia. And Olivia is 40 meters behind Nadine, who is ahead. In your diagram, use M for Meg, E for Edith, and so on. Okay. So let's make some more room here. I'm going to go ahead and draw a line starting here. And I'll just put dashes. Okay. All right, so here's kind of a little line here. Okay. So we're gonna start with Meg is 20 meters behind Edith. So you go 20 and then you get E to Edith. Edith is 50 meters ahead of Wanda. So here's Wanda, 50, Edith. So Meg is 20 meters behind Edith. Edith is 50 meters ahead of Wanda. And Wanda is 20 meters behind Olivia. So Wanda is 20 meters behind Olivia. Olivia is 40 meters behind Nadine. So Olivia is 40 meters behind Nadine. Okay. So I'm going to start with the biggest number first, I think. Probably the easiest, which is this one here. And I'm just going to put, let's see, I'll put E over here. And that's 10, 20, 30, 40, 50. So W right here. That's that 50. And then I know M is right here. And then O is ahead. So here. And then O, and then 10, 20, 30, 40. Okay, let's make sure. Is that right? Okay, I think that's it. We got it. So it looks like the answer would be Olivia. Because the one is ahead. Or wait, hold on. Typo. I'm like, this should be N. And yeah, that should be N. So it is Nadine. Because you do end up spelling woman here. Okay. Number 4. Mary Ann is building a fence around the outer edge of a rectangular garden plot that measures 25 feet by 45 feet. Will she set the posts 5 feet apart? How many posts will she need? So Mary Ann is building a fence around the outer edge of a rectangular garden plot. Okay, so before we do this, I'm going to erase everything from number 3. And okay, so there is a ink to shape here. Oh, I guess there's not. Okay, so I have a rectangular garden plot that measures 25 feet by 45 feet. She will set the posts 5 feet apart. How many posts will she need? Okay, well, let's see. You got 1 here. And then, so that's 0, that's 5, 10, 15, 20, 25, 30, 35, 40, 45, right? So that's 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 on this side. And then we're going to go 5, 10, 15, 20, 25. And so we already counted this one, so that would make it just 5 on this side. And it should be pretty self-explanatory to see that it's also 5 on this side. So now I have all these here, and then I'm going to have the same amount over here. The only difference is I'm actually not going to count the corner ones this time, giving me 8 there. So that's 10, 20, 28. 28 posts. Okay, cool. Freddy the Frog is at the bottom of the, well, here, before I move on, let me erase everything from the last one. Okay. Freddy the Frog is at the bottom of a 30-foot well. Each day he jumps up 3 feet. But then during the night, he slides back down 2 feet. How many days will it take Freddy to get to the top and out? Okay, so there's a little, hold on. Okay, so 30-foot well, each day he jumps up 3 feet. So first he jumps up 3 feet. Jumps up 3 feet. Goes down 2, then he's at 1. Jumps up 3 feet. Goes down 2, then he's at 2. And then he jumps up 3 feet. Goes down 2, then he's at 3. So depending on, so first day, he jumps up 3 feet, goes down 1. Second day, during the night, he slides back down 2 feet. We're going to have to be careful like how we define day 0. So it could be the first day, he slides up 3 feet, slides down 2. The second day, he's at 1. This is day 2. And then day 2, he gets to 4 feet. Day 3, he gets to 5 feet. Oh, I see. Day 4, he's actually going to get to 6 feet. And then he'll slide back down to 4 feet. And then on day 5, he'll go up to 7 feet, slide back down to 2 feet at night. So 30 feet, I think it should take 28 days. Because it looks like to me, you're 4 to 6, 5 to 7, 1 to 3. So that would be 28 days. 28 days. Cool. Let's check the answers here. And number 2, you're going to take a legal left turn. It's true. Yes, number 2, the answer is yes. S Street is a lettered street, so it runs north to south because S is on a vowel. S Street must be a two-way street. Because it is an even-numbered street, 14th Street must run one way east. The finished diagram indicates that a car traveling south on S Street can make a legal left turn onto 14th. Number 3, number line on which each tick mark represents 10 meters. Mark the given information on the number line. The final diagram will show Nadine is ahead. Draw a diagram. She will need 28 posts. 28 days. You can draw a vertical number line representing the well. Mark the number line to show Freddie's location at the end of each day, D1, D2, and so on, and the end of each night, N1, N2, and so on. After marking the results for several days, you should begin to see a pattern. At the end of day N, Freddie is N plus 2 feet from the bottom of the well. At the end of night N, he is N feet from the bottom of the well. So Freddie will reach the top of the 30-foot well on day 28. Okay, that concludes 2.1 homework.